All right, so today's lesson is based on domain and range of functions. So we got to first learn what is a function, how can you tell if it's a function or not, okay, and that's pretty easy. And then once we figure out whether or not it's a function, we got to understand how can we tell the domain of a function and the range of a function, and what exactly is domain and what exactly is range, right? So like I said, if you want to write down notes, right now is the time you're going to want to do it at this point. But eventually, I'm going to tell you, you might just want to stop and just kind of pay attention to the pictures because that's what your homework is going to be based on. Okay? So, first off, how to tell if we're just going to say f of x is a function. Okay? So, how to tell if an equation is a function. So, what you're going to do is you're going to use the vertical line test. Now you guys should know this vertical line test, right? You've seen it before? You just draw vertical lines over a graph, and if it touches more than once per line, then it's not a function. If you've never seen it, right now I'll show it to you guys. Okay? So vertical line test basically does this. I'm going to draw some lines for us, okay? So here's a curve, okay? Here's another curve. And let's say here's a graph of an ellipse, and here's another curve. Actually, that's more of a line. So, how can I tell if these are functions? Okay, so what I'm going to do is I'm going to draw vertical lines. Now, you don't have to literally draw them. You can just pretend that you're drawing them like in your head. But notice that first graph that I did. Does that graph get touched more than one time per blue highlight line that I did? Or maybe I should change it to green here. So look, does this line touch it more than once? No, right? What about this line? Does that touch the graph more than once? No, right? That one or this one, like, do any of these touch it more than once? No. Now, some people say, well, yeah, it touched it 7 times because you drew 7 lines. Yeah, but individually, per line, just one time, right? So I'm going to say that this is a function, okay? That is a function. Now check this out. Does that touch it more than once? No. This one? No. This one? Yes, 3 times. As soon as it touches it more than once, then you say it's not a function. Okay, so what about like this one right here? Just once? Twice. Not a function. What about the last one? Is that one going to be a function or not? Yeah, this will be a function. Look. Just one time. So is it hard to figure out if something is a function or not if you're given a picture? No, just draw vertical lines, okay? And based on that, you should be able to tell whether or not something is a function, okay? So if it touches more than once, it is not a function. If it touches only once per line, then it is a function. So anybody unclear on that? So a pretty easy idea, vertical line test. There's another one called the horizontal line test, but that's for figuring out some other stuff. But we do the vertical line test to tell if something is a function. Now, of course, this only works if you have a picture, right? Don't get an equation and start drawing lines over it, right? You got to have a picture of what it is that you're looking at. So, all right, so how to tell if it's a function? Use the vertical line test. Now, what is domain? So domain is how far left and how far right a function expands. So in other words, how far left and how far right does it go? Sometimes pictures have arrowheads and they keep going to the left and they keep going to the right forever, right? But sometimes some graphs have like little dots. So you might see graphs that look like this. Arrowheads mean that they keep going to the left, they keep going to the right, okay, or to the left and to the right, okay? They keep going forever and ever and ever. But then sometimes you'll see some graphs that look like they go to the left forever, but then they like stop at a certain point, right? Or maybe they're like this, okay? Where they start and stop at certain areas. Now you'll notice the open circle means it does not include that point, right? Whereas the closed circle means that point is included. But you see a lot of different things. For domain, all you want to know is how far left and how far right does it go. Okay, and anything, let me not draw it that way. We're kind of measuring, right? So measuring from here to here. So we'll do examples right now, okay? But I'm just trying to give you an idea. So domain is how far left, how far right. Range is how low to how high. Okay, so remember, always start left to right with domain, from left to right. Range is always from the bottom up. Okay, like if you're filling a cup of water, right, from the bottom up. So what is range? So how low to how high a function expands. Okay, so how low to how high a function expands. So if I were to get these same pictures, I don't know if this is going to work, but let's try it. All right, cool, it did work. So same exact pictures. Range is like this high to this high, right? From here to here, from here, right? That's what I'm trying to measure. That right there. How low to how high. Sometimes it's easy because you can literally see the beginning of the low part to the end of the high part. But if you see arrowheads, that usually means it keeps going on forever. What do we call it when something keeps going on forever? Infinity, right? Now, here's one unfortunate quirk for you guys. Your homework is going to be on quizzes, okay? It's going to be on quizzes. And when you do it on quizzes, you're going to have to actually write the word infinity. So if you go negative infinity, meaning, either all the way down or all the way left, you're going to have to type negative infinity, okay, with no spaces. Or you may have to type infinity, because they don't give us the little symbol, right? They don't give us that symbol to put in on quizzes. So when they ask you to give them the answer, you're going to have to type in infinity and negative infinity. Now, one last thing before we actually go over these pictures. I think, and tell me if I'm wrong, but have you guys ever done what's called interval notation? So, let's say an equation exists from -2 to 4. Have you guys ever done this? Does that look familiar? Okay, so I see a lot of you guys saying yes. That's called interval notation. Okay, that's basically saying the same thing up on top. Now I just want to remind you guys, less than or equal to or greater than or equal to, you're going to use these brackets, okay? That means it includes it. It's or equal to. But if it's just like less than or greater than, you got to use parentheses for that. Okay? One thing, anytime you write the word infinity, you always use parentheses wherever the word infinity is. So let me give you some examples. If you had something that went from 3 to infinity, you must put a parenthesis anywhere you write the word infinity, whether it's negative or just normal infinity. Now the 3 could be either a parenthesis or It could be a bracket based on what you see, okay? So we'll kind of mess with this in a bit, right now when I draw pictures. But the 3 can be included or it can be excluded. Excluded, you use a parenthesis. Included, you would use a bracket, okay? Infinities, always brackets. So sometimes if you have to go from negative infinity to positive infinity, if that's going to be, let's say, your domain, make sure you have parentheses. You can never use brackets on infinities, okay? Infinities always have to have those parentheses. So let me show you what your homework is going to look like. So we'll start up here. Actually, you know what? These are a little bit on the tougher side, so we'll end with those. Notice the instructions here. It says, state the domain, state the range, and tell us if it's a function. So let's start with the function first, okay? Look at question number 1. Is question number 1 a function? Let's see. Do I ever touch, let me change to green, something a little bit easier to see. Do I ever touch that line more than once when I'm drawing those vertical lines? No, so that means it is a function. Okay, so function. Okay, A and B are domain and range. So domain, how far left does this thing go? How far left does it go? Well, right here, this is -1, right? So -1, how far right does it go? Let's see, 1, 2, 3, 4, 5. Does it include the -1? Is it a dark circle at -1? Yes, so I'm going to put a bracket. Is it a dark circle at 5? Yes, so I'm going to put a bracket. Remember, we're just trying to figure out how far left and right it goes, okay? How far left and right. I don't care that it's going up and down. I just want to go left and right, okay? So that's my domain. My range, how low is it? Well, that's right here. -1 again. How high does it go? What's the highest point you see? What's the y value for it? Like it's right here. That'd be 1, 2. That's the highest point, right? So let me erase all this just so you can see a little better. This point is 1, 2, 3, 4, 5, comma 2. And this point right here is -1, -1. Right? So the lowest it goes is -1. The highest it goes is +2. You guys see that? Right? As low and as high. Just think of it as how low does it go, and then you climb up until the graph stops. The height of it is at a 2. It is a black dot on both sides, so I do include it. Yeah. So there's your answer for domain. This will be your domain. This will be your range. And then when they ask you if it's a function, we said yes because, it doesn't touch more than once. Okay? This next one's a little weird, but it's not hard. Check out this next problem. Is it a function? This next one right here. Well, let's see. Does it ever touch more than once? No. So is this a function? Yes, right? So this is a function. Okay. How far left does it go? Ignore the height. Just look at left. How far left does it go? We're looking at that graph right there. How far left does it go? Close. -2, but you're thinking this way, right? It went that way to 2 units to the left of the y-axis, right? So -2, right? Because that's where it is. Here's -2. That's -2 right there. That's the left side. How far to the right does it go? Let me erase these lines. Maybe that'll help here. How far to the right does it go? 4 units. Should I include the -2? Yes, because it's a dark circle. Should I include the 4? No, so I'm going to put a parenthesis. Okay, the parenthesis means not included. The bracket means it is included. This next part's kind of weird. How low does that line go? I mean, it basically stays at one height, right? So isn't the lowest it goes and the highest it goes the same value? What is that value? What's the height of it? What is that? 1, 2, 3 units, right? So you're just going to do this. That's just a set of, meaning here's the only number that works for it, just a 3. So you put it in a brace, okay? You don't have to, but a lot of people like to see it in a brace, okay? So my range is just 3. It only goes to the height of 3. It doesn't go any higher, it doesn't go any lower. It's just at 3. But the domain goes as far as -2 and all the way to +4. That's as far as it goes. That's its domain, okay? All right, let's try one more of these here, and then we'll move to something different, unless there are something. Oh, yeah, we can try these down here. So, is this a function? Well, does it pass the vertical line test? Let's see. Does it ever touch more than once? No, right? So this is a function. So, function. All right. How far left does it go? Ignore the heights and stuff. Just think left-wise. How far left does it go? So, yeah, so look over here. That's as far left as it goes, right? What is that number? That's a 1 on the x-axis. How far to the right does it go? Well, it goes all the way up to here. What is that number? That's a 1, 2, 3. So it goes from 1 to 3, right? It goes from 1 to 3. So from 1 to 3. Should I include the 1? No, because there's an open circle. Should I include the 3? Yes, because the circle's closed. Now, what's the lowest that it goes? What's that number, in terms of height? What is the lowest that it goes? 0. And then what's the highest that it goes? 5. Yeah. Should I include the 0? No. Should I include the 5? Yes. Okay, because there's a solid dot at the 5, but there's an open dot at the 0. Okay? So let's do a kind of weird looking one. Look at question 5. Is this a function? No, right? You can automatically think like if I draw a line, it's going to touch twice at certain places, right? So I'm already going to put right here, not a function. After this, we'll go somewhere else to do some other problems. But for now, let's just do this one. All right, domain. How far left does this circle go? Give me the x value. How far left does it go? I think you said it. So let me zoom in a bit more if I can. Just how far does that go? Like what is this number right here? That'd be 1, 2, 3, 4, 5, 6. So -6. Okay, that's a -6 right there. How far to the right does it go? That's going to be 6 right here, +6. Now we don't see any circles, right? So that means that it's a nice complete circle that includes all those points. So I'm going to include it because you can tell that the ellipse is a nice complete circle. There's no holes in it, right? There's nothing missing from it. It looks like a nice complete circle. How low does it go? 0. How high does it go? Say again? 4, yeah. Does it include 0 and 4? I mean, yeah, there's no hole, right? If it didn't, there'd be an empty circle there. Okay? But since there is no empty circle, it does include it. So there's your domain and range. Okay, again, I want to do a lot of these with you. Okay, this is why I told you don't take notes, because we're going to be going through tons of graphs and kind of quick. But is it okay so far? Is it kind of making a little bit of sense before we go into any of these other crazier looking graphs? It doesn't matter how weird the graphs are, by the way. It just matters left, right, bottom, up. That's it. Who cares what the graphs look like? So let's check these out. So you can see there's a couple other ones here, but I'm gonna move on to these right here. All right, let's try this one. Okay, because we haven't done anything that has infinities in it. Okay, so we're about to try to do some stuff that has infinity in it. So first off, is this a function, number 4? No, right? It's gonna fail. Okay, it's gonna fail there and there and there and there, right? A bunch of twice that is touching it, so it's gonna fail. The domain. So think about this. Notice how there's an arrow on the top left corner. That arrow means it keeps going to the left and up forever. You guys understand that, right? The arrow is telling you that it's going that way, so it's going up and to the left forever. Okay? So, how far left does this graph go? Negative infinity. So I'm actually going to do it like this, but remember on your homework, you're going to have to write out the word infinity. Okay, because there's no symbol for it. So you're going to have to put negative I-N, right? I-N-I-F-I-T-Y. So how far to the right does this go? What's the furthest to the right that it reaches? Check again. Isn't it right here? Right? Isn't that the furthest to the right that it goes? So what's that number? 3. It includes the 3. Should I include the infinity? No, right? Infinities are never, ever included. Okay, my range. How low does it go? -2. Good. This is the lowest that it goes right there. -2. How high does it go? To infinity. Because remember I told you this arrow right here is saying that it's going to the left and up forever. Right? It's going that way forever. So that means you're going towards infinity. Should I include infinity? No. Should I include the -2? Yes. That's your domain and range. We're going to do more of these, okay? If you have questions, let me know. Let's do number 5. Notice this one doesn't have any arrowheads. That means infinity is not going to occur, okay? Is this a function? Yeah, that's a function, right? Because I could draw a bunch of vertical lines and be like, look, and never touch more than once. Right? So that is a function. How far to the left does it go? Just think left. Who cares about its height? Just how far to the left on the x's do you see it going? -4. Good. -4. How far to the right? 3. Notice here's the -4, right? And here's the 3. Right? That's how far it moves, left to right. Should I include the -4? No, because notice it's an empty circle. Should I include the 3? Yes or no? Yeah. So there we go. All right, range. How low does this go? What's the lowest you see it drawn? At -5. And what's the highest? At 2. Good. Should I include -5? I mean, there's an empty circle, so I shouldn't include it. Should I include the 2? Well, I don't see any dots, but that's fine as long as there's no open dot. I don't see any dots, so that means I get to include it. Okay, so there's your domain and range. This is how you do it. You go left to right, bottom up. Okay, and then if they ask you, is it a function, then you get to do that. Now, let me do one of these that's a little weird. So number 9. Now, this one's a little weird because you see how it has arrowheads? That means that it's going to the right and up forever. And this one's going to the left and down forever. It's never stopping. So when I ask you, well, first off, is this a function? You would say, yes, that is a function. Okay? But if I ask you, what is its domain? How far left does this graph go? Well, you're going to say left is forever, right is forever. So my answer should be what? Negative infinity to infinity, right? So remember, you're going to have to write it, type it out on your homework. Here, I'm just going to go like this. And remember, never include the infinities, put parentheses, right? How low will this thing go and how high will it go? Well, look, I told you it's going to go down forever, up forever. So, yeah, but make sure you always start negative first, right? The smaller one first. So negative infinity to infinity again, okay? So sometimes you will get answers like this, okay? Where it is going, to the left forever, to the right forever. So make sure you put negative infinity to positive infinity, always with the parenthesis with the infinities, okay? Now let me just check to see, is there one that you guys would like to try to figure out from one of these? 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, let's look at 7, right? Let's check out number 7, and then we'll stop. Because I think after that, the rest should be pretty good. So, first off, is number 7 a function? Yeah, this one is. Look, I can just draw a bunch of vertical lines, and it's never going to touch more than once, right? So we're good with the function portion. What is its domain? So how far left does it go? Negative 5. How far right does it go? 4. Does it include negative 5? Is there a nice solid dot there? Yeah, right? Does it include 4? Well, yeah, it's going right through. It's right here. The dot's right here. So it is including that. Notice it does include 5 and 4. So there you go. What's the lowest that it goes? What do you guys see? A negative 3. Good. What's the highest that it goes? A 3. Should I include the negative 3? In other words, do you see an empty dot there at negative 3? No, that means it's included. Is there an empty dot at 3? No, so that means you include it as well. Okay? So yeah, these are weird looking graphs and stuff, but the work you're doing is not like, okay, let's calculate stuff. You're basically just trying to write like how far left does it go, how far right does it go, how low does it go, to how high does it go. Make sure you guys keep your numbers in order. In other words, smaller numbers go first, bigger numbers go second, okay? If you write infinity, it should be negative infinity to infinity, right? Stuff like that. I think that's basically all I wanted to go over with you guys. You know what? Let's do this one really quick. Sorry about that, but I just figured try to give you some weird situations. Is this a function? No, right? It's gonna fail there and there. So not a function. So let me just write right here, not a function. How far, for the domain, how far left does it go? So where's the furthest left that this thing goes to? Like, wouldn't it be right here? That's the furthest left it goes. What is that x value? 0, right? Good. 0. How far to the right does it go? Notice arrowheads. So that means it keeps going forever. So how far right does it go? In other words, this direction. It goes to, what do we call that if it keeps going forever? Infinity, right? Notice I am going to include the 0 because it is part of the graph. Okay? Now, how low does this graph go? Notice this one's going down this way forever. This one's going up this way forever. So how low does it go? Does it keep going down forever? Yeah, so what do we call that? Negative infinity, right? And then how far up does it go? To positive infinity or just infinity, right? So there you go. I wanted to do this one because this one's a little weird, right? It's a little weird. It has arrowheads that go down forever, up forever, but they only go right forever, not left forever. So we actually do have a domain that doesn't have infinities on both sides. So this is what your homework is like. You're going to have like, I think 4 questions where they're only going to ask you, is it a function or not? Okay? And then the rest of them, they're going to give you a picture and they're going to say, what's the domain or what's the range, right? So you're going to have to type that in. I don't think any of it is multiple choice besides the function ones. Like, is it a function, yes or no? I think you have like 2 or 4 of those. But after that, the rest you're typing in through quizzes, okay? So I'm going to give you guys the assignment right now. Let me stop this.